All right, 7th hour. This is actually 2nd hour, but I'm not going to be here today. Obviously, you know that by now. So I'm going to use 2nd hour to help you get better today. Are you guys excited, 2nd hour? Okay, the first thing we're going to do is get out our assignment. Please, go ahead and take that out. That means you guys too. I'm going to read the even answers to the assignment. Okay, let's see here. Answer to number 2, 0. Is that correct?
Yes.
Okay. Make sure I'm on the right things. Here we go. 2 is 0. 4 is pi over 2. 6 is negative pi over 4. 8 is negative pi over 4. 10 is pi over 3. 12 is pi over 4. 14 is negative pi over 6. 16 is 0. So all those you should have been able to do in your head. See a lot of erasing. Not good. Make sure, not a lot of erasing. How many of you got them all right? That's 3 people, 7th hour. I hope you guys raised your hand and Mr. Lip could see how many. Okay, 18. Now this was with the calculator in radian format. 18 is 0.47, 20 is 2.35, 22 is 1.50, 24 is 1.31, 26 is negative 0.13, 28 is 1.23, and 30, 1.91, and 32, negative 1.50. Do I need to repeat anything? Okay, let's go over anything you missed right now. Ask some questions. Obviously, 7th hour, hopefully they'll have the same questions you have. Okay? Usually, that's how it works out. Okay, what do you guys got? No questions?
16. Throw them out.
16. Okay, what was the question in 16?
Inverse of cosine 1.
Cosine inverse of 1. So, this 1 is the ratio. We're looking for theta, basically. Anytime you take inverse of a trig function, you're looking for theta. So what this means is cosine of some theta equals 1. Well, there's a lot of times that cosine equals 1. But if you remember, this theta for inverse cosine, the answer or the range of it has to be between 0 and pi. So what radian measure between 0 and pi does cosine of that angle equal 1? Think about your unit circle. Where is cosine 1? Cosine is x, right? At pi, what's cosine? Negative 1. So it's at 0. So cosine inverse of 0 equals 1. That was number 16. Okay. Any others? How many of you, did anybody ever put like 7 pi over 4 when you did a sine inverse or a tangent inverse? Did anybody ever get like 11 pi over 6? What were some other things? Yeah.
That was mine for 14. I put 11 pi over 6.
Okay. And it was supposed to be negative pi over 6, right?
Yeah.
So was it tangent inverse or sine inverse?
Tangent inverse.
So it was tangent inverse of negative root 3 over 3, right?
Yes.
Okay, so you're looking for a theta that makes tangent equal negative root 3 over 3. So by now, hopefully you're remembering that the reference angle that gives us this is 30 degrees, and the quadrant that makes tangent negative is either 2 or 4. Well, yesterday when we did tangent inverse, we learned that the answer had to be between negative pi over 2 to pi over 2. Okay, so quadrant 2 is out because negative pi over 2 to pi over 2 is either in 1 or 4. Okay, so if you go 30 degrees in quadrant 4, some of you are going to want to say, well, if we go around all the way around, that's going to be 11 pi over 6. But 11 pi over 6 is bigger than pi over 2. If you punch in 11 pi over 6 on your calculator, you're going to get like, 11 times pi is roughly 30, probably 36, divided by 2 is going to be like 18. This is 1.57. Okay? No, 11 pi over 6 wouldn't be that big. Over 6, I divided by 2. It's going to be around, remember it's going to be around 6 radians to 11 pi over 6. Not 18, so closer to 6. But that's bigger than 1.57. Okay? So, tangent inverse of negative root 3 over 3, you're going to state it as, just go this way, negative pi over 6. Okay? Anybody else get quadrants confused? Did anybody say 5 pi over 6 for this one? I went to quadrant 2. Anybody do that? Come in through it in front of the camera to show that you're late. You got to pass or what? Okay. All right. Any other questions? Okay, you're going to continue to work on this today. And today what I've got, a couple things, all right? Remember, here's the deal. When you take a trig function of a theta, you're going to get a ratio. Now, for the most part, you can take the trig function of any angle. Tangent's going to be undefined when we're on the y-axis. Cotangent's going to be undefined when we're on the x-axis. Secant's going to be undefined when we're on the secant's 1 over cosine, so when we're on the y-axis, and cosecant's going to be undefined when we're on the x-axis. But other than that, you can take sine, cosine, tangent, whatever, of any angle and get a ratio back. Now, a lot of the angles you're going to have to do on your calculator. But if it's a 30, 45, 60, or on an axis, if it's one of those reference angles or you're on an axis, you can do it in your head. All right? So this should really never be restricted except for when you get something divided by 0. Now, you've been doing that a lot. All right? Now, when you take sine inverse, you're going to take sine inverse of a ratio, you're going to get a theta back. Okay? Here's the deal. The ratio has to be between negative 1 and 1, or it's undefined. The theta has to be between negative pi over 2 and pi over 2. Just giving you this in a little bit different way today than I did yesterday. Okay? Cosine inverse of a ratio is going to also equal a theta. The ratio, once again, is going to be between negative 1 and 1. And the theta is going to be between 0 and pi. Okay? And tangent inverse of a ratio, is going to equal a theta also. Now, anybody know what the ratio has to be? Anybody remember that from yesterday?
Sine.
That's your theta. The theta is going to be between where and where? Negative pi over 2 and pi over 2. And the reason I don't include those is because you can't take the tangent of pi over 2 and the tangent of negative pi over 2. Okay, but what about the ratio? No restrictions on it. You can take tangent inverse of anything. Okay, so when you get a problem, it's really important that you understand what you're getting asked to find. Okay, so just do 2 more problems here. Then get you going here. If you're asked to find, let's do cosine of, let's do pi over 6. You've probably done this problem 10 times. What am I looking for? And what am I given? What is pi over 6? It is a radian. It's a radian. Okay? Cosine of theta. It's theta. It's an angle. And when we get done, we're supposed to figure out a ratio. Now, is pi over 6 a place that we've studied in detail? It is a theta we've studied in detail, right? What's the reference angle?
30 degrees.
Okay. What's the quadrant? 1. Cosine at a 30 degree is what? Cosine is x. So what is it? What'd you say? No. It's root 3 over 2. Cosine x, 30 degrees, the wide, short triangle. So x is the long leg. And is it positive or negative? Quadrant 1 is positive. So that you should be able to do in your head. Okay? Now, if I asked you to find cosine inverse of pi over 6, you're going to want to think cosine of pi over 6 because that looks like a radian. Now what is the pi over 6? It's a ratio. Now here's the deal. Anytime you take cosine inverse of a ratio, that ratio has to be between negative 1 and 1. So is pi over 6 between negative 1 and 1? Well, what's pi about? 3.14. And if I divide that by 6, is that going to be less than 1? Yes. Now 2 pi over 6, or pi over 3, would not. So, cosine inverse of pi over 3 is undefined. Because that is bigger than 1. But cosine inverse of pi over 6 exists. It can happen. Guys, what it means is, I want to find it. What am I looking for if I'm finding cosine inverse of pi over 6? I'm looking for a theta. And I want to find a theta. Now it's either going to be in quadrant 1 or quadrant 1 or quadrant 2 that makes cosine a ratio pi over 6. So since it's positive, it's going to be quadrant 1. Cosine's positive in quadrant 1. And basically what it means is that my adjacent is 6, or I'm sorry, my adjacent is pi, and my hypotenuse is 6, and I'm looking for the theta. That can happen. You can have this be pi and this be 6. As long as the legs are smaller than your hypotenuse, then you're in good shape. So what are we going to have to do to find this answer?
Calculator.
Use a calculator. And all the answers for these inverse, we need to be in radians. So go ahead and punch that in. And what do we get?
1.02.
So you know where that is? That's right basically where the radian, where the arc length and your radius are equal. Is where that's going to happen. Okay? All right, I'm going to give you the worksheet. You can do the worksheet you can do the problems on the worksheet. Some of the answers are given on the back. All right, and we'll move on from this tomorrow. Anybody got any questions before we go? All right.